All right, so for our last section, 10.4, we're going to look at something called the distributive property. And so before we do that, I'm going to look at what does modeling this look like, and it'll actually make a little bit more sense for us about what's actually happening when we're solving these equations. All right, so distributive property questions will look something like this. Let's choose. Let's choose smaller numbers actually, just to make this a little bit easier for us. There. Okay. So what's happening here is we have this 2, and this 2 is telling us that this right here, we have 2 of it. All right. So I'm going to show you modeling wise what this is actually saying. So let's remember our legend. All right, we've got our big boxes with X. Okay, that's 1X. Then we have our little boxes colored in. That's going to be +1. And one that's not colored in is going to be -1. Okay, and so I'm going to just model this X plus 3. So I have an X, an unknown box, and then I have 3 positives. Ones. Okay, great. And that's going to be equal to, on the other side of the scale, we've got 12 positives. So, the only thing really here that's different is this 2 in front. And what that 2 is telling us is that we have 2 of this group. So this right here, this section, this X plus 3, we have that 2 times. So I'm going to double it. So I'm going to have the X and the +3 and the +3. So I have 2 of them. Okay. So when we look at this equation, what we'd actually rewrite it as would be, how many X's do we have? Well, we have 2 X's, and we have 1, 2, 3, 4, 5, 6, plus 6 equals +12, right? And now we would solve it the exact same way we would do other modeling questions, all right? We'd have to we just want 1 X, all right? We got 2 X's right now. So we just want 1 X, and so we would first balance this out with negatives, because remember, a positive and a negative gives you 0. These cancel out. But what I do to one side, I have to do to the other, so I have to add 6 negatives to the other side. These are going to cancel. 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 And these are going to cancel. So what I'm left with now is I've got these 2 X's. Okay, I didn't do anything with them. And they're equal to, and what we're left with up here is 6 positives. So 1, 2, 3, 4, 5, 6. And so what we have to do is we have to figure out, well, how many little positive ones go to 1X? Okay, we got to split these in between 2. All right, well, I can put these 3 here, and the same amount has to go to the other one. So in 1X, we would have 3 positives, and that is how we would get our answer, okay? We're splitting or dividing 6 positives among 2 X's, all right? And that's going to give us X is equal to 3. Okay, so if we recall this, we learned this in say even 10.1 with our modeling. It's the exact same thing in this situation. The only thing we changed is this number out in front. We're going to say we're going to double this. All right, so however many numbers you have up here, that's how many times you have whatever's in the bracket. All right, so if I do another one, if I have 3 times 2X plus 1 equals 9, okay? then again, what I do, I draw this part on the inside of the bracket first. So I've got 2x's plus 1 equals positive 9. And they're all colored in because it's positive 9. Okay, great. And then what this is telling me is I have 3 of this, 3 times this inside. So I'm going to box that off. That's 1. I'm going to have it again. And a positive. I have that a second time. And then I have it a third time. There we go. Okay, and so my new equation would be 1, 2, 3, 4, 5, 6 x's plus 1, 2, 3 positives is equal to positive 9. And that would be the equation we'd solve, which is exactly like 10.2. All right, the same modeling as 10.2.